Today, we'll explore the critical topic of ethics and the profound societal impact of artificial intelligence. Our focus will be on navigating the responsible development and deployment of AI, ensuring its benefits are shared equitably. First, let's delve into understanding bias within AI systems, a crucial step for fair and equitable technology. We'll identify the various points where unfairness can originate, helping us address it effectively. One common source is data bias, which occurs when the training data itself is flawed. This bias happens when training data fails to represent real-world scenarios accurately, leading to skewed outcomes. For instance, facial recognition trained primarily on one ethnicity may struggle to identify others accurately. Next, we have algorithmic bias, which stems from the design choices made within the AI algorithm itself. This bias arises directly from how AI algorithms are designed, influencing their decision-making processes. An example is an algorithm that prioritizes certain features, which could unintentionally favor specific demographic groups. Lastly, we consider human bias, which is often inadvertently introduced by the developers themselves. These are unconscious or conscious biases that developers introduce during the AI system's creation and training. For example, selecting features based on personal or cultural preferences can embed bias into the system. Now, let's discuss the serious consequences of bias to AI, understanding why addressing this issue is so critical. Addressing bias is critical for building trust and ensuring equity across all AI applications. One major consequence is discrimination, where biased AI systems can lead to unfair outcomes for specific groups. These systems can unfortunately replicate historical prejudices, leading to unjust treatment for certain populations. Another critical consequence is the significant loss of trust in these intelligent systems. Public trust diminishes when AI systems are perceived as biased, especially in sensitive areas like healthcare and finance. Furthermore, organizations face severe legal and ethical consequences for deploying biased AI systems. Proven biased AI systems can result in costly lawsuits and significant reputational damage for organizations. Fortunately, there are many proactive ways to mitigate bias in AI development, ensuring fairness from the start. We'll explore key steps to foster fair and equitable AI systems, making them trustworthy and inclusive. First, we need diverse data collection to ensure our training datasets accurately represent all demographic groups. Regular algorithm auditing is crucial to identify and correct any inherent biases within the AI's decision-making logic. Implementing human-in-the-loop oversight means human experts continuously monitor and refine AI decisions. Transparency and accountability are vital, requiring clear explanations of AI decisions and established responsibility. Finally, utilizing specialized bias detection tools can automatically identify and flag potential unfairness in AI systems. Today, we'll delve into measuring fairness in AI outputs, a critical aspect of responsible AI development. We'll begin with an introduction to quantitative fairness metrics, providing a structured way to assess AI impartiality. Our first metric is called demographic parity, a fundamental concept in understanding group-level fairness. This formula shows the probability of a positive predicted outcome for Group A must equal that for Group B. Here, y hat equals $1 / y equals $1 represents a positive predicted outcome from our AI model. The variable A denotes a sensitive attribute, such as gender or race, that we are examining for fairness. Variables A and B represent different demographic groups within the sensitive attribute, like male and female or racial groups. In essence, demographic parity aims for equal positive outcome rates across all the different demographic groups. This metric ensures that the proportion of individuals receiving a favorable prediction is similar across all designated groups. Importantly, demographic parity focuses solely on the predicted outcomes, irrespective of the true underlying labels. Next, we'll explore equalized odds, another vital fairness metric that offers a more nuanced perspective. This formula requires two conditions: equal true positive rates and equal false positive rates across groups. In this context, y equals $1, y equals $1 signifies a true positive outcome, meaning the actual label is positive. Conversely, y equals $0, y equals $0 indicates a true negative outcome where the actual label is negative. Again, y hat equals $1 backslash hat y equals $1 signifies the positive predicted outcome from our I model. And A equals A and A equals B still represent the different demographic groups we are comparing. Equalized odds specifically seeks to achieve equal true positive and false positive rates across different demographic groups. This metric ensures fairness by considering both positive and negative true outcomes, making it more comprehensive. It specifically addresses fairness while taking into account the ground truth labels, unlike demographic parity. Now, let's shift our focus to the crucial topic of protecting privacy within AI systems. We'll explore the key challenges involved in data handling and security that arise when developing and deploying AI. A primary challenge is ensuring proper data collection and obtaining informed consent from individuals. We also face challenges in securely storing data and determining appropriate retention periods for it. Managing data sharing, especially with third parties, presents significant privacy considerations and risks. Protecting against data breaches and identifying system vulnerabilities are constant and critical security concerns. Even with anonymization efforts, the risk of re-identification remains a complex and ongoing privacy challenge. Let's outline the fundamental data protection principles that guide ethical and legal data handling in AI. These principles are essential for guiding ethical and legal data handling practices within the realm of artificial intelligence. First, we have data minimization, a core and crucial principle for responsible data management. This means collecting only the data strictly necessary for the AI system's purpose, avoiding excessive or irrelevant information. Another key principle is purpose limitation, which dictates how collected data can be used. You must use collected data strictly for its stated purpose, never extending its use without explicit consent. Transparency and accountability are crucial for fostering trust and ensuring responsible data governance. This involves clearly communicating data practices to users and being accountable for all data handling procedures. Robust security measures are absolutely vital to safeguard sensitive information and prevent unauthorized access. Implement strong protocols like encryption and multi-factor authentication to protect data from any unauthorized access. Finally, upholding user rights empowers individuals with significant control over their personal data. Ensure users can access, rectify, delete, or port their data, empowering them with control over their information. Let's summarize the essential pillars that form the foundation of responsible AI governance. Transparency ensures that AI systems are understandable and their decisions can be clearly explained. Accountability means assigning responsibility for AI system outcomes and their potential impacts. Fairness focuses on ensuring AI systems treat all individuals and groups equitably, without bias. Safety and security involve designing AI systems to be robust, reliable, and protected from harm. Privacy protects personal data, ensuring it is handled responsibly and in compliance with regulations. All right, class, let's wrap up our discussion with a quick summary of what we've learned today. Here are the key takeaways from our session that I want you to remember about AI ethics and societal impact. AI bias can arise from data, algorithms, or human input, leading to discrimination and a significant loss of trust. To mitigate bias, strategies like ensuring diverse data, conducting regular algorithm audits, and maintaining human oversight are absolutely crucial. Achieving privacy in AI demands explicit user consent, secure data storage, and robust protection against any re-identification attempts. Data protection principles emphasize minimizing data, limiting its purpose, ensuring transparency, strong security, and respecting user rights. Effective AI governance frameworks promote transparency, accountability, fairness, safety, and privacy throughout the entire AI development process. Lastly, AI impacts employment by both displacing and creating jobs, making new skill acquisition essential for the workforce.